So here you have the result, or the example of chloride and bromide to illustrate the isotopic mass and what is the advantage to measure isotopic mass. So here you have the example of chloride. This is the mass spectra of the chloride, and you see if I only detect the chloride, I have a chloride 35 and a chloride 37. And if I have the resolution, I am able to separate, to detect these two isotopes. And I have the 35 here corresponding to the chloride 35. And I have also the 37 here corresponding to the chloride 37. And the ratio represents 75 and 25 in terms of intensity. Of course, there is nothing in 36 because in 36 you have no isotope. For the bromide, this is quite similar. This is between 79 and 81. So in 80, there is nothing. And we have two peaks corresponding to these compounds. So this is the two isotopes of bromide. The bromide 79 is represented here, and the bromide 81 is represented here. And you see that the relative intensity is similar because, it's similar because this is 50-50 between bromide 79 and chloride 81. So we obtain the detection of the isotopic ratio of the element. And then it means that if I have a bromide in my molecules, I have always something like this for the isotopic profile. So concerning now the example of molecules, it was for the elemental analysis. Now you have an example for molecules, and that's the example of bromomethane, CH3Br. What is the isotope of the molecules? So I have the question, what are the isotopes of these molecules and their abundance, of course. So the first one, we have a carbon, 3 proton, and a bromide. The carbon is like this. It is first a C12 carbon because this is 99% of C12 carbon. We have 3 proton. Proton is considered as 100% proton 1. And we have the bromide, which is 79%, which is the bromide 79, and the relative abundance is 51%. The mass, the monoisotopic mass, corresponds to the carbon, 12, 1 times 3, of course, and 79. It means that we have a mass of 94 Dalton. Then if I represent the relative intensity and in my mass spectra, I have a peak corresponding to 94 Dalton. And this peak corresponds to 100% because it is the major isotope of the molecules. Okay, now we have to consider the second isotope. The second isotope is this one. We have a carbon 13 now, and the relative intensity, the relative abundance is 1% as compared to the carbon 12. We have, of course, the protons and the bromide 79. The difference between these two isotopes is a difference of 1 Dalton because you have carbon 12 and carbon 13. So the mass is 95 Dalton. And considering now the relative abundance, you see that we have 1% of this molecule, so this isotope, as compared to this one, because we have 99% carbon 12, 1% carbon 13. Then if I represent the mass spectra, I have the 45, I have an isotope, but it is here 1% and 95% of 49. Okay, Now I have to see that I have other isotopes, because I have also isotopes due to the bromide. Then I have the C12 protons and the bromide 81, and this is 49%. It means that, of course, in that case, I have C12, H, so this is 3, and 2 more as compared to this one. Because here and here, that's quite similar, but I have the difference of bromide 79 and bromide 81. Then the mass is equal to 96 Dalton. And concerning the intensity, the abundance, I see that I have the same abundance for the carbon, same abundance for the proton, of course, and a quite similar abundance for the bromide. Then I have in 96 a peak corresponding to these isotopes and the relative abundance of these isotopes, which is quite similar to the 94. Okay, another and the last one is the same isotope with the bromide 91, but in that case with the carbon 13. The carbon 13 allowed to obtain now an addition of 1 Dalton as compared to these isotopes. Here we have a value of the isotopic peak in 97 Dalton, and we have an abundance between these two isotopes. The only modification is concerned the carbon, so we have to compare the carbon. We have 90% of this one as compared to 1% of this one. Then we have in the 97 this spectra, this abundance, relative abundance, which is 1% as compared to this one. And here you have the mass spectra, the isotopic profile of the molecules of bromomethane. That's very important to understand this example because it can explain very well the isotopic profile. This isotopic profile is related to these molecules. It is not possible to have these molecules and to have another isotopic profile. The fact that we have a bromide is shown here by these two peaks and correspond to the 50-50 proportion of the bromine 79 and bromine 81. So we have the identification without ambiguity of the molecules.